All right, these are notes number 5. They are the first notes for this week. You should already have your paper set up from the beginning of class. If you need to do it though, go ahead and pause. These are notes that are all about angles. The essential question, how do I use the list, which is the PDF on PowerSchool, to solve for different types of angle relationships? So we should have done this proof in class already. Moving on up. We're going to start with some of the postulates, which are rules that are in the list. So I'm starting with the first postulate, which is in the middle of the list, and it's called the segment addition postulate. And postulates, like I said, they're rules. It means that we don't need to prove them. We just like follow them like if it's a rule, like a law. You don't question it, you just do it. You need to follow the law. So it's a postulate. So segment addition postulate is pretty basic. I'm just gonna go through it. I'm not gonna do an example because there are examples in your ALEKS assignments that you've done. So it says that segment AB, given that diagram, plus BC, so that one, equals the whole segment, which is AC. So basically, if you have a segment, but then it's divided up, like there's a point in somewhere, this is not the midpoint, but there's a point somewhere, it breaks it up into two smaller segments. Those two segments add up to the whole. That kind of makes sense. So that's segment addition postulate. You will possibly use this as a reason in the future in some of your proofs. All right, here's the next one, which is really similar, but it has to do with angles. So as we go through, I know some students get confused between segments and angles. Angles are always talking about this part in between the two. It could be segments or lines or rays, but the space in between, it's like I don't know, it's the angle. Whereas the segment is always based off of like a straight line, and then it could be broken up into multiple segments, or you could be comparing segments. So always try to keep in mind, what is the difference? Are you talking about angles or are you talking about segments? So it basically says the same thing, like I was saying. An angle can be broken up, and again, it's not exactly in half because that would have been the angle bisector. This is different. It's just some kind of array. In this case, it's ray BC goes through the big angle and breaks it up into two parts, not equal parts, but into two parts. So those two parts equal to the whole. And it's written out right here, so I'll go ahead and highlight them. We've got measure of angle ABC right there, plus measure of angle CBD. So see that those are the two smaller parts. Those add up to, I'll use yellow again. Those add up to measure of angle ABD. The big one, this one. So when I highlight it like that, you could easily see the green angle plus the pink angle equals the yellow angle. So if you know the actual degrees that they equal, you add them up and it equals the whole. Okay, so that's angle addition postulate. And again, these are from the list. Once you understand these and you see the list, you should kind of just know like what each one is, and it will help you. It is very helpful. Okay, we've got this one from the list. Linear pair of angles are supplementary. So there's a lot of vocabulary in this one. And you guys, whenever you need to, just Google what something is and you'll get answers, and that can probably help you. Or look it up in your notes because a lot of this stuff we have written in our notes already. A linear pair, a pair is two. Linear means a line. So linear pair of angles are two angles that make up a line. Or basically, if you think you have a straight line and you can have a ray or a line go through, or even a point. A point can make it, no, not a point for these, sorry. But a line or a ray or a segment could go through and make two angles on the same line. Supplementary, that means that they add up to 180 degrees. I'm going to add a little note. Supplementary means 180 degrees. So angle 1 plus angle 2 equals 180. because it's a linear pair. Whenever you have a line, think that the degrees of that whole line is 180. So anyways, what this says is that angle 1 is supplementary to angle 2. Angle 1, which is right here, this whole angle, whoops, is supplementary to angle 2. I'll get a different color. And again, you just have to know that vocabulary, get used to it. Supplementary means 180 degrees. Okay, and we'll do examples on the later part of the notes. And then I did write that in a note down here. Definition of supplementary angle says measure of angle 1 plus measure of angle 2 equals 180 degrees. And that definition we wrote on another set of notes, and it's also on the list. All right, and then this last thing, this is a really important theorem. It's our first theorem I think we're talking about. So this is on the list. It's a theorem, and theorems must be proven. We will not spend the time right here to prove it, but feel free to look it up. Like if you have some free time, Google vertical angles theorem proof and see what it is. It is interesting to see, but we're not going to do it right now in the notes. So whenever you see two lines, in my mind, I just think they make an X. They cross. So two lines that cross and make an X. You get vertical angles. I'll go ahead and mark them. Like 1 and 2 are vertical angles whenever they're across from each other. And we can show congruence using a little arc like that. And then there's two other angles that are congruent, but they're not the same. If you actually just look at how angle 1 is formed, if you kind of trace over it, at least on mine, and then angle 3, you can kind of tell that angle 3 is smaller and angle 1 is larger. Angle 1 seems obtuse, it seems larger than 90, and angle 3 seems acute. So they can't be the same. Angle 1 and angle 3 can't be the same. I mean, if I drew it differently, maybe they could be, but the way I drew it here, they're not. So I'm going to show that angle 3 has two blue arcs, and angle 4 is its congruent angle. They're vertical angles. So angle, and I wrote it right here. Angle 1 and 2 are, angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. And what congruent means, again, is that they have equal measures. So congruent means that they have equal measures. One thing I also want to mention while we're here is that 1 and 2 are congruent. They're the same. But like 1 and 3, they're a linear pair. Look at this. They're two angles on a line. So remember from up above what a linear pair of angles are. They're supplementary. You'll start to see that there's a lot of connections being made. So that means that, angle 1 and 3 would add up to 180 degrees. Angle 1 and 2 are the same. Angle 3 and 4 are the same. So that kind of helps you if you need to find all the measures of the angles. It's a quick way to find all of them. So anyways, using vertical angles are congruent like this. You would then, if you're doing a proof, using definition of congruence, you can say that the measure of angle 1 equals measure of angle 2, and that measure of angle 3 equals measure of angle 4. So that is the vertical angles theorem. All right, so now we're going to do some examples where you use these, and it'll help you in the ALEKS homework. Remember, you got to do these notes first before you do the assignment, because these notes are going to teach you, and then you practice in ALEKS. And remember the Cornell notes setup. When you're all the way done with the notes, make sure you go back and you get your 3 questions per page. So you'll need 1 question, a second question, and a third question. And at the very end, you'll want to do your summary. Okay. So anyways, now we're going to do some examples. Oops. Okay. Trying to get it lined up right. Make sure you title what this is in case if you're just randomly flipping through. It's notes number 5 continued. You want your name, date, and period. Okay. So do these notes first and then do your alex.com, and then you can use these to help you. So number 6, unless if I'm wrong, but it should, like, I don't know if it scrambles it up, but there is a problem. It's probably number 6. It uses the angle addition postulate. Look back in your notes, just the other page right there, and try to remember what that is. We have the diagram, and again, you guys pause if you need to just draw everything out. We have a big angle, and then there's this ray that goes through it. And then we are given measure of angle 2 is 50. And I see measure of angle 2 would be right in there. And measure of angle GFH is 80. So always look at all your information first, and then I'm going to fill it in. And I need to find measure of angle 1. So I'm going to circle that. Things can get pretty complicated, and you'll have to really know what exactly are you solving for. What is it asking you to find? Okay, so I'm going to write in my information. I'll use a different color. Okay, so I know that measure of angle 2 is 50 degrees. And I know that the big angle GFH is 80. If you really want to show it, this isn't the best way to show it, but I would just show like from there to there is 80 degrees. It just helps me see the picture a little bit better. So according to the angle addition postulate, these two angles, angle 1 plus angle 2, would equal the big angle, angle GFH. So I'm not doing a proof, so I don't need to make it look super formal or anything. I would just show measure of angle 1 plus, I'm going to substitute already. Okay, I guess I'll just write it already because I think you guys know. I'll just put in 50 for that one, and that equals the total whole angle, the measure of angle GFH, which is 80. And you could even probably just figure it out without making an equation. All you'll have to do is subtract 50 to 80, and you can probably do it mentally. So that way I end up getting measure of angle 1 equals 30 degrees. Don't forget the degrees. That is what the question asked me to find. I want to double check that. Find measure of angle 1. Okay, got it. I can also check my answer. So I can go back, put the 30 in. It would be measure of angle 1. If that is 30 degrees, does 30 plus 50 equal 80? Yes. So I can check my answer without even writing anything down. I can mentally check it. Yes, it is correct. Okay. You guys pause if you ever need to. Like if you need to copy something down. So number 7, the next one, it will use the linear pair of angles are supplementary. So again, linear pair, there's a line with 2 angles on it. Those 2 angles are supplementary, meaning they add up to 180. So again, since this is just giving us the actual numeric value, there's not an algebraic expression, there's no x's or anything, that makes this really easy to solve. So I'll explain it though. Once you see how to do it, you'll see it's pretty easy. Measure of angle 1 is 40. So that angle is 40 degrees. And then it says find. This is what I need to be finding. Find measure of angle 2. That's this one. Okay, so we know that they're linear pair. We know that they're supplementary. Really, you guys, all you got to do is 180 minus 40. And subtract, and I get 140. So that should be measure of angle 2. I'm going to double check it though. So measure of angle 2 should be 140. I did 180 for the whole line, and then I subtracted the 40, and that should be 140 for angle 2. The way I check it is if those two add up to 180, I know I'm right. 140 plus 40 is 180, so I know I've got it. So that is correct. Okay. And let me slide this up. Okay, so now we've got this one. It's a little bit more complicated, so I wanted to spend more time on this one. Like I've been saying, pause if you need to so that you can copy it. We are given the measure of angle 1, but see now it's an algebraic expression. We have a x term and a number term. So angle 1 is right there. And then we've got measure of angle 2. right here, and it's another algebraic expression. And what we need to do is find the angle measures. Find the angle measures. So my final answer is going to be measure of angle 1 equals something, and measure of angle 2 equals something else. So you got to think, what do we know? I know, just like we did in the last one, linear pair of angles are supplementary. So angle 1 plus angle 2, measure of angle 1 plus measure of angle 2 equals 180 degrees. That's a fact. Like we know that for sure. That's a postulate. Okay. So what then I also know I can substitute. I know angle 1 is 10x plus 24, and angle 2 is 4x plus 16. So then I can just write underneath this, and this is almost like a proof. I'm just not writing out the reasons, I'm saying the reasons. I can substitute, use a substitution property to put my 10x plus 24 plus the 4x plus 16. That equals 180. And now I can just solve and I'm going to get x. So where I'm at right here, I need to combine like terms. So I would add my 10x with the 4x, always take the sign in front, and then I would combine the 24 with the 16. So I'm combining like terms on the same side. The 180 is alone on the right, it's just going to stay there. All right, so 10x plus 4x is 14x, and then 24 and 16 is 40. Yeah. Okay, so now it's an easier equation. I kind of see very clearly what I need to do. I have to subtract 40 to both sides using the addition POE. So see how I'm saying the reasons, just to get you guys used to proofs. Sorry, it's the subtraction POE. But you could say it's adding a negative. So sometimes we say that. So subtraction POE, and then we got 14x equals 140. And now all I have to do is think about what's this property called. It's the division POE, division property of equality. So if I divide that, and you guys can use calculators whenever you want, I end up getting 10 as my answer. Yay, I'm done. Just kidding. You got to see, what is it actually asking you? It is asking you to find the angle measures. Well, I found x, yay, but I need to find the measure of each angle. So measure of angle 1 equals 10x plus 24. It's given and it's in my picture. All I have to do is put 10 in for x. So I would do 10 times 10 plus 24. 10 times 10 is 100 plus 24. This should be my answer, but I'm going to check it at the end. So 124 degrees. I'm going to check it just to make sure. And then for measure of angle 2, looking at the given information, it is 4x plus 16, but I'm going to substitute in 10 for x. So that would be 4 times 10 plus 16, 40 plus 16. So measure of angle 2 equals 40 plus 16, 56 degrees. Okay. How can I know if those two are correct? Just a real quick way. How can I tell? You got to think where they are in this diagram, angle 1 and angle 2. They should add up to 180. So that's what I would do. I would just check to check it to make sure, because I might have made a mistake with the x. I might have made a mistake in this part solving. So you want to try to check it and see if you did everything correct. I would just do 124 plus 56, and if it equals 180, then I'm good. Then I know I'm correct. So 4 plus 6, 10, carry the 1, and then that would be 5 plus 3, so 8, and then 1. So it is 180. So then I know that I'm correct, and that these are the two correct answers for the measure of angle 1 and the measure of angle 2. You can also go back and write the answers in if you want, 126 right there, and then 56 for this one. Okay. So that's probably your first time doing a problem like that. I think once you get the hang of it, it's pretty fun. Math can be fun, you guys. So it involves solving an equation and substitution. And when everything works out and it's actually correct, it's pretty nice. It's like a nice feeling, like I actually did it right. It's good. Okay, so anyways, last problem. You will have a problem like this one or actually a few in ALEKS. Let me just make sure there. Okay, so for problems 12 through 14, we'll be using the vertical angles are congruent. So that was the last part we wrote on from the list. It's a theorem. A theorem has to be proven. If you Google it, you can see the proof. So I'll just assume you can do that. Given that measure of angle 4 is 110 degrees, find measure of angle 1, measure of angle 2, measure of angle 3. So the reason that I know to use vertical angles are congruent is because I basically look for the x. You would have two lines that cross, and then you get four angles in the middle. It's not always numbered like this. It doesn't really matter. Usually, depending on whatever it is, they'll number them maybe differently, 1 and 2 across, 3 and 4 across, or 1, 2, 3, 4. This one did counterclockwise, 1, 2, 3, 4. So it's just, don't worry about like the numbering, just go based off of the diagram. Anyways, I'm going to look at my given information. Measure of angle 4 is 110, right there. I'm going to write it in with pencil. This whole angle is 110 degrees. It makes sense because it looks like it's more than 90. So it's 110 degrees, an obtuse angle. What I need to do is find all of these. That's what my final answer will be. Okay, so I need to find measure of angle 1, 2, and 3. I need to find all of those. So using the vertical angles are congruent, you might need to check back on the other page, like how I was showing. It's basically the angles across are congruent. Angles across are congruent. Angles next to each other form a linear pair, and they add up to 180. So that's what I'm going to use to find the missing angles. Okay, so I want you to think, if angle 4 is 110, which angle, 1, 2, or 3, is the same? One of them is congruent, so it has an equal measure. So if angle 4 is right here, which angle has the same? It's always the one that's across, if you just go straight across. They look the same too. So again, this is a theorem. It's proven, so we can use it. So measure of angle 2, I'll go ahead and just write it so you guys know what this looks like. Measure of angle 2 is congruent to measure of angle 4. And that's because of the vertical angles are congruent. And we know based on the definition of congruence that they would then have equal measure. Measure of angle 2 equals measure of angle 4. So I just have to see, what is angle 4? It's 110 degrees. Measure of angle 2 equals 110 degrees. And that's kind of like substitution. So that's done. So I've got 110 right there. I can fill it in my diagram. Those are both 110. 1 and 3 are also the same as each other, but they're not 110. Think about, how would you find these missing angles, knowing that they're a linear pair and that linear pairs are supplementary, which means that they add up to 180. So for measure of angle 1, it's congruent to measure of angle 3 also. We just have to figure out what it is. So I hope you're thinking that you should do 180 because of the supplementary angles minus 110, and we end up getting 70. So 70 degrees for measure of angle 3. Oops, sorry, I should not be putting the m's here. When you're talking about congruence, you don't put the measure. Angle 1 is congruent to angle 3. You don't have to erase it if you put it in pen, but try to fix that. Okay, so angle 2 is congruent to angle 4, but when we're talking about measures, it's measure of angle 2 is equal to measure of angle 4. So angle 1 right here is congruent to angle 3. So measure of angle 1 equals measure of angle 3. And they both equal 70. And you can just double check, like I like just looking at the diagram. The linear pair should equal 180. Every linear pair, 70 and 110 is 180. 110 and 70 is 180, like every way around. And then the ones that are across are vertical angles. They should be congruent, so they should be equal. Okay, so just to finish up writing my answer, measure of angle 2 is 110. Measure of angle 1 equals 70 degrees. Measure of angle 3 equals 70 degrees. Is that what it was asking me for? Yes, and I've already checked it because I was checking the linear pairs and the vertical angles. So just to show you real quick, this is probably what I would have done like if you were in class. So if I have this, you have vertical angles that are congruent across and across. So like these, like what if I say this one is 100? This one kind of looks like it could be 100 degrees. Can you find all of the other angles? This one, and this one. If this one's 100, can you find this one and this one and this one? So what you should do, this is just how I do it real quick. Across from it's the same, it's 100. Next to it, I would do 180 minus 100 to get 80 degrees. So 80 degrees here, and then across 80 degrees here. So that's how you can do it real quick to find the measures of vertical angles and linear pairs. All right, so make sure you guys get your summary. Go move on to Alex number 5 assignment, and good luck, and I'll see you later.